Hello, I'm going to prove the negative angle identities for sine and cosine. Now, it's easy to remember that sine is odd and cosine is even, so this property is easy to remember, but how do we prove it? Well, I can rewrite this as sine 0 minus theta, and that would give us the difference identity, so sine 0 times cosine theta minus cosine 0 times sine theta. Now sine 0 is 0, so this whole thing cancels out. This equals negative cosine 0, which is 1, which just gives us sine theta, and we can do the same thing here. So and like I said, it's easy to remember that sine is odd and cosine is even, therefore that's why these properties hold. But to me, this is a definitive proof that shows us why these are. Hello, I'm going to prove the negative angle identity for tangent. Now, once again, tangent is an odd function, so it's easy to remember this rule based on that property. But I'm not going to use the difference identity like I did with sine and cosine. Instead, I'm going to transform tangent negative theta into sine negative theta over cosine negative theta, because I think this is easier. So that's why I've got these written down. A sine negative theta is negative sine theta, and cosine negative theta is cosine theta. Once I do that, I see I've got sine theta over cosine theta, which is tangent theta with a negative sign left over. And if we take cotangent negative theta, we can prove it the exact same way, just with cosine on top and negative sign on the bottom, giving us negative cotangent theta. And finally, we'll go over the negative angle identities for cosecant and secant, just by the same way of setting this equal to sine over negative theta. So putting it in terms of sine, and we get 1 over negative sine theta, and there is our cosecant with a negative left over. Here we can do the same thing, getting cosine negative theta, which just gives us 1 over cosine theta, and that's already equal to secant theta. So there are all your negative angle identities in a nutshell. Your period identities in 1 minute. Proof of all your cofunction identities in 1 minute. Let's go ahead and prove the half angle identity for sine. So I'm going to let t equal x over 2. This implies that 2t is equal to x. So I'm going to rewrite this as sine t is equal to plus or minus the square root of 1 minus cosine 2t, all divided by 2. Now I'm going to go ahead and square both sides. I get sine squared t is equal to 1 minus cosine 2t all over 2. We'll multiply by 2, giving us 2 sine squared t equals 1 minus cosine 2t. And then we'll go ahead and switch sides with sine t squared and cosine 2t. So we get cosine 2t is equal to 1 minus 2 sine squared t. Okay, so this gives us a double angle identity for cosine 2t. So let's go ahead and prove the half angle identity along with some additional caveats. I'm going to go ahead and let t equal x over 2, implying that 2t will equal x. So this makes me rewrite it as cosine of t equal plus or minus the square root of 1 plus cosine 2t all over 2. So the next step is to square both sides. I get cosine squared t equal to 1 plus cosine 2t divided by 2. And now we're going to go ahead and multiply both sides by 2. We get 2 cosine squared t equals 1 plus cosine 2t, and we're going to subtract 1 from both sides. We get 2 cosine squared t minus 1 equals cosine 2t, and now we have a double angle identity proving our original result.